Let's understand how to figure out or how to tell whether two lines that are being intersected by a line that will be transversal of those two lines, whether those two lines are parallel or not. If you look at this figure, we have line Q and R that is being intersected by this line P that will be the transversal for these two lines. On the basis of this given information that these two angles are 50 degrees, you have to tell whether lines Q and R are parallel or not. Now you will say that, hey, you know what, by simply looking at this figure, and if we look at these two lines, we can tell, yes, line Q and R are parallel. But in mathematics, we don't proceed in that way. We have to prove by, calculation or whatever, and you have to tell how the two lines will be parallel or not. So if we look at this transversal, and if we look at these two angles, then you can clearly see that this angle is 50 degree and this angle is 50 degree. What does it tell us? It tells us that in this case, these two angles are actually what? They are alternate interior angles. So this angle 50 degree and this 50 degree are alternate interior angles, and in this case they both are equal to 50 degree. That is, they are equal. Since the alternate interior angles are equal, therefore these two lines Q and R are parallel. Okay. If you look at these two lines Q and R, and this is a transversal, in this case P. Now what information has been given to us is that this angle is 50 degree and this angle is 130 degree. Now tell whether these two lines Q and R are parallel or not. To tell this, if you take this angle 50 degree and just focus on this angle, this one. So if we look around this vertex here at this point, and if you look at this line and this line, you can clearly see that this 50 degree, and let's say this is X, this X and 50 degree are linear pair, right? They are linear pair. Now since X and 50 degree are linear pair, therefore X plus 50 degree will be equal to 180 degree, and therefore X will be equal to 180 degree minus 50 degree, and this will give you X is equal to 130 degree. Therefore X is equal to 130 degree. Okay. Now look at this angle. This is 130 degree and this is also 130 degree. So don't you think that this angle and this angle is actually what? Is a pair of corresponding angles. A pair of corresponding angles, and both the angles are actually equal to 130 degree. That is, in this case, this pair of corresponding angles is of equal measure. Therefore, line Q and R are parallel. Had it been the case that these two angles were not equal, in that case, even if it would have been 129 degree, even in that case, these two lines Q and R, we would not say that they are parallel. What about this one? In this line M and line N, and this is a transversal L, the information that has been given to us is 126 degree and 44 degree. These two angles are 126 degree and 44 degree. Now, we can see that these two angles are actually what? They are internal angles on the same side of the transversal, on the same side of the transversal. 126 degree is an internal angle, 44 degree is an internal angle, and they are on the same side of the transversal. That is, in this case, they are towards the right of this transversal. In this case, these two internal angles, sorry, this should have been internal, not interior. These two internal angles are actually alternate. Why? Because they are on the opposite sides. One is towards the left and one is towards the right. But in this case, they are on the both. These both angles are on the same side. Therefore, in order to be, for these lines to be parallel, M and N, this angle, the sum of this angle and this angle, that is the sum of internal angles on the same side of the transversal, should be equal to 180 degree. So if you add them, 126 degree and 44 degree, you will get actually what? 126 plus 4 is 130, and this is actually what? Is 170 degree. Right? This is 126 degree, and if you add this 126 to 44, you are getting 170. So can you look here? These two lines are actually looking parallel, but they are not exactly parallel because the sum is coming to be 170 degree and it's not supplementary. That is, it is not equal to 180 degree. Had the sum been 180 degree, then we would have said yes, they are parallel. What about this one? In this case, again, you'll have to tell by the calculation. Line M and line N, you have to tell whether line M is parallel to N or not. Okay. So this L is a transversal. This angle is 75 degree, right? This angle is 75 degree. Now, what would be this angle? Because this 75 degree, and let's name it X, these two angles are actually linear pair, right? X and 75 degree, they are linear pair, they are forming linear pair. So if these two adjacent angles are linear pair, therefore X plus 75 degree will be equal to 180 degree. It means that X is equal to 180 degree minus 75 degree. It gives you X is equal to 105 degree. Now if X is equal to 105 degree, so let me write it here. This angle is 105 degree. Now this angle, that is 75 degree, maybe some different color. This 75 degree and this angle and this angle are what? Are pair of corresponding angles. They are pair of corresponding angles. Again, this angle and this angle, these two angles are pair of corresponding angles, but in this case, one is 75 degree and another is 105 degree. It means that these two angles are not equal. Therefore, they are, line M and N are not parallel. When they would have been parallel? When this angle and this angle, both these two angles would have been of the same value. At that time, we would have said, yes, they are parallel. In this case, we have line M and N, and you have to tell whether M is parallel to N or not. L is a transversal. Now, if you look at this transversal line here, so if I focus on this one and focus on this one, around this vertex, this angle and this 57 degree, let us name it as A. So this angle A and 57 degree, they are actually linear pair. So A and 57 degree, they are linear pair. And since they are linear pair, therefore A plus 57 degree is equal to 180 degree. And if you solve it, you'll get A is equal to 123, 130, 123 degree. So this angle is what? Is coming to be 123 degree. Now, this angle and this angle, right? These two are actually what? Pair of corresponding angles. Why? Because this is also above this line and this is also above this line M. Therefore, they are pair of corresponding angles, and pair of corresponding angles in this case is what? Is actually 123 degree, right? So pair of corresponding angles is 123 degree and they both are equal. Therefore, yes, this line M and N are parallel. This line, let's say this is M, this is N, and this is L. You have to tell whether M is parallel to N or not. Okay. So in this case, if you look here, we have these two lines M and N, and L is a transversal. If you focus on this line, so around this vertex, you can see that this 72 degree, and let's name it as A. A and 72 degree are what? They are actual linear pair. Since A and 72 degree, they are linear pair, therefore A plus 72 degree should be equal to 180 degree, and if you solve this, you will get A is equal to 180 minus 72, and you will get 108 degree. So this A comes out to be 108 degree. Now if you look at this angle and this angle, these are actually what? They are alternate internal angles, right? This angle and this angle, these are alternate internal angles. And since these two angles are not equal, because one is 98 degree and another is 108 degree, therefore we will say that line M and N are not parallel. So this was a problem on the topic how to tell whether lines are parallel or not when they are being intersected by a transversal. So let's quickly, revise 3 points. What all 3 points you have to check when you have to perform calculations to tell whether lines are parallel or not. First point is pair of corresponding angles should be equal. Now, those of you who don't know about this theoretical portion, please check my previous videos. We have discussed in depth, in detail about these things. Pair of corresponding angles should be equal. And next point you have to check is alternate internal angles. Alternate internal angles should be equal. And the third point is that the sum of internal angles on the same side of the transversal is equal to or is supplementary. by supplementary itself, it means that they should be equal to 180 degree. Okay, like in this case, where did we, yeah, in this case we saw, right? Okay, so here we proved that the sum of internal angles is on the same side of the transversal is not equal to 180 degree, right? So if any of these 3 points, any one of these 3 points is being satisfied, then you will say that yes, lines are parallel. If not satisfied, then they are not parallel.